All right, so here's the underlying deep idea here. So the top is what we've been indoctrinated to think about. And so, information gets delivered to agents in pieces. So everybody gets a sample. And so as you collect more information, your understanding of the facts becomes more precise. And because all the information is dispersed, then we can rely on the law of large numbers, and prices are going to reflect all information. Okay? And so we're really well indoctrinated into that. Now, the paper takes issue with this approach and thinks that there's another process that's really taking place, where every agent gets all the information, but they have to sort it and find out what's relevant. Okay? And so only the most essential information is going to be passed on, and that's going to be in prices. Okay? And so, at first glance, this could look like just, the same thing. You could maybe extend the top version to be the second version, but actually there are other ideas. This is an idea that I think that we should probably take seriously, okay? And so, Sims has this idea of rational inattention. As all this information comes pouring down on us, how do we actually sort through this? How does asset pricing affect, how are assets priced? Now, in work that I've done recently, you can actually show that information consumption about assets, when it spikes, there's a risk premium associated with that. And it usually arises due to spillover from announcements of other firms. So even when no news has been released by a particular firm, the fact that people go back to that information and update their beliefs given what they've seen, that's actually priced in markets. So this sorting seems to be relevant to how markets might work. Okay, and so this is the backdrop. So now we move into the laboratory. Okay, and so I wanted to, a lot of us don't know all the experimental evidence of how information gets aggregated in the laboratory and so forth. You could even write a book on it, okay? So that's been done, okay? And so if we look at aggregation of information, the majority of studies in the laboratory essentially say that aggregation of information is incomplete, okay? Even if you go back to Plot and Sunder, which happens to be a seminal paper where they claim and they show in the laboratory that you can get aggregation of information, if you relax the assumption that some of the participants are perfectly informed, you don't get full aggregation, okay? And so, it's not clear in the laboratory whether we can get aggregation. And we're not sure if is it the laboratory, or is it really that we don't get this happening in markets, okay? So what do they do in this paper? Well, they look at a sorting problem. And the sorting problem is packing your bag on a trip, okay? And so, I think Peter did a good job at least giving you an idea of sort of you have to, look at everything that you can put in the knapsack and figure out what to put in there. Now, this is a hard problem, okay? This is not easy, okay? It's not something that most people can just simply solve. And in fact, as you make it more and more complicated, it becomes impossible. Virtually impossible, okay? And so there are heuristics that people use to solve these problems. So Peter mentioned the greedy algorithm, and that you would basically start with the best thing that you can put in the bag and the next best, and you just keep going down. That's a very common thing, but that's wrong, okay? Random sampling, just say, well, let's try this big one and try this one and try this one. That's also wrong. Another thing that Peter has documented in the past is that people have inertial thinking. They try the first product the first good, and they leave it in there too long. They get stuck on it, okay? So you have these various, things that people do. They're heuristics. One question I have is does using this approach with this packing of a bag, is this imposing a certain type of bounded rationality on people when they participate in the lab, okay? It's not, because you know that they're going to do some of these things wrong, is there actually, are we really looking at bounded rationality in the lab or full rationality? Now, Peter mentioned this science paper about how markets can help solve problems. This is a science paper from 2009, and as he said, they compared two settings. One in which you had a bunch of people try to solve a knapsack problem, and the first person to do it gets a prize. Everyone knows that. The second, there is no prize, and you try to solve it, and you trade in the market, and then you get a payoff based on your trading. The payoff is spread among everybody in the second setting. So the question is it really the market price that's helping them to solve it, or is it incentives? Because it's a completely different, one's a prize, winner take all. The other is incentives for, you're trading in a market. You're not getting paid the prize. And in fact, the authors in the paper say that if you change the setting in the first case to not announce when the person solves it, that you can actually get the solution rates to be very similar. Okay, so that leads us, to, this study. Okay, so this study is made up of two experiments. And so the experiment one is very similar to the science paper. Okay, you're basically have these knapsack problems of varying difficulty, which are called SONI K, okay, depending on how difficult. You have these digital options that pay off on all the potential items that are in the knapsack. The ones that are in are the good ones. The ones that are bad, you shouldn't be betting on those, okay? There's a bunch of items, 10 to 12 items that could potentially be put into the knapsack. And they used 78 University of Melbourne students. Now, those aren't common Australians. Those are University of Melbourne students. I would have to imagine they're pretty good people. Okay, and so how did they make money? They make money by submitting some answer, okay, participating, showing up, and then trading. Okay? So what do they find? Well, they find that the more difficult the problem is, the worse the performance. Okay, that makes sense. Another thing they find is the higher the difficulty, the more moves people make, so they have to put in more effort. That also makes sense. Now, here are some puzzling results. There was no relationship between the difficulty and the trading volume. Okay, that could have gone either way. There's no relationship between the difficulty and what people earned. It's also odd, right? Especially since if one person solved a very hard problem, they could earn a lot. And the trading volume and the optimal items and the other items were no different from each other, okay? And the performance of the market knapsack, which was sort of what ended up in the market, which was high and which was low, was worse than the individuals, okay? So, why could this happen? Well, first of all, diversification motives. I mean, you're solving a hard problem. People are risk averse. Now, they claim to solve this by just giving them the fixed participation or by having them, just give a solution, but that's not really solving risk aversion. That's almost meeting a reservation utility, okay? And so could they be holding on to multiple assets when they don't really know which one is the right one? And could that be blurring things? Second of all, there's a lack of trading because maybe the students are trying to solve the problem, but they're not traders. And so I could imagine a situation where, let's suppose I'm with a bunch of, PhD students in engineering trying to solve this. I realize they're going to get there first. So I just sit there and watch the prices. And as soon as one of them starts betting on this and betting on that, boom, I just free ride, right? Does this happen? Maybe they should look at later versions of the traders to see, are they actually doing this? Because this would be, if you keep losing, then you should be free riding. Do they actually do this and just watch prices and react? Okay? And the last thing about this experiment is maybe we should be looking at some more common people, especially because this is a tough problem. Experiment 2, as Peter said, now the main difference is you have one traded security. That's supposed to be your oracle. Okay? Now, of course, with the oracle, the solution rates are improved, and, of course, it doesn't make the problem easier, but it does help optimal stopping times. Okay? So now, of course, the assertion is that this is because of an incomplete market. Incomplete markets are better. But there's no hedging motive here. There's also less attention required. Instead of following 10 markets, you're following one. And so while the complexity of the KP is unchanged, maybe it would be perceived as more simple. Now, the last thing I want to say, and I want to come back to this, because, Peter has done seminal work, and his team. And I think the idea of this is the rational expectations setting. Is that right? Is that paradigm right? Or is the sorting right? And what I'd like to see is an experiment of some sort that does a horse race. How does the aggregation in the lab change when you do these things? Intra-individual, not like kind of doing one study over here and one study over here. Intra-individual. And if they have the choice to learn through the signals or the knapsack, what do? Okay, that may give us some insights into what are people doing in the world. Should we be thinking about a new paradigm of sorting as opposed to what we've been indoctrinated into? And I think this is set up to do that. Okay, so I think that the research is ambitious. I think we should be revisiting our paradigms. I think the experimental setup can be changed to answer some very fundamental questions. And I really commend the authors for being so ambitious and brave in taking this kind of thing on. This is what we need. So thank you very much.